Hi, my name is Klaus Langout and I work in the Azure Storage team. I'm really excited today to talk to you about scaling your globally distributed workloads with object storage. In this session, we'll cover an overview of object storage, talk about some key workloads and customer examples, do a short demo on NFS v3, switch gears and cover Azure Data Lake Storage, which is built directly on top of our object store, and then touch on the WAN Disco Live Data Platform for Azure. So in Tad's session, you got to hear about the entire storage portfolio. In this session, I'm diving deep on object storage, which is Azure Blob Storage and Data Lake Storage Gen 2. If we look at the larger environment, there are some specific projections to keep in mind. The first is the astronomical explosion of data. By 2025, projections are that we will hit 175 zettabytes of data, roughly quadruple of what it is today. And 1 zettabyte is equivalent to 1 million petabytes, to give you a slightly different way to think about that number. The second factor is that the majority of this data is unstructured. Providing the right platform to store, manage, protect, and extract additional value from this data is key. Now, looking at what the transaction rate is that we process in Azure Storage today, during the 30 minutes that this session is projected to take, we will have processed 360 billion transactions. So I first want to touch on what unstructured data is. Basically not structured like a database with a schema. Unstructured data includes types such as files, whether produced by an end user or a system, such as a change order or an invoice. Media, including audio, images, and video. IoT and device data, whether from an autonomous car sensor array or the thermostats we have in our homes. And lastly, backup and archive data from both on-premise produced as well as in the cloud. So I first want to dive into what Azure Blob Storage is. It's highly scalable, being able to store tens of petabytes in a single account, and provide multiple redundancy choices to protect from drive, zonal, or even regional failure. We also include security features, including AED authentication, policy, config, network security controls to ensure protection of your data. We also have costs down to $1 per terabyte a month, coupled with features such as last access lifecycle management, where objects can be moved to lower cost tiers if not frequently used. Besides management lifecycle, we also include features to make it easier to understand what your data state looks like, even if it's billions of files/objects within a storage account. And last, we include premium tier, which is SSD based, for your most demanding workloads, including HPC and analytics. So now that I've talked about what Azure Blob Storage is, let me talk about what it's good for. The first is cloud-native applications, applications designed in the Azure cloud from the ground up that make use of the unstructured data storage capabilities of Blob. The second is machine learning and AI and HPC. Even though there are some differences, they both have a need for high throughput, high capacity, and in some cases, low latency. That can also be enabled through tools such as HPC Cache or Blob Fuse. The fourth one is backup and archival workloads, where you have lots of cold data that you want to maintain for a longer period of time. And lastly, we have analytics, which we enable through ADLS Gen 2, which sits direct on top of our object store. Now, I've mentioned the $1 per terabyte a month a couple times, so I want to provide a picture of all the different tiers we provide. On the far right, we have our two low-cost tiers, Cool, which is online, and Archive, which is offline. So the cost of Archive is so low that you can replace your on-premise tape libraries with Azure Archive Storage, which helps a lot because you don't have to worry about upgrading your LTO tape versions or dealing with the hardware mechanics of those tape libraries. And you can lower the cost even further with reserved capacity, which can lower the cost up to 38% more when you purchase in blocks of 100 terabytes or 1 petabyte with 1 to 3 year duration. And I previously mentioned lifecycle management. So an example of that would be to set a policy where after 7 days of not being read, a blobber file can be moved from hot to cool. And then after 188 days of not being read, it could be moved from cool to archive. And then after 7 years, deleted from archive. And that policy is completely in your control as far as what those durations look like. Now, the two tiers on the left include premium where Premium is SSD based, which provides very low and consistent latency and much better small object performance than Hot. Now for workloads which are very high as far as transactions per second, Premium will also in some cases be cheaper than Hot, while providing that better latency and that better throughput and performance. So I did want to touch on 3 of the newer features we have coming out. The first one is NFS v3 protocol support on top of our blob storage. NFS v3 enables both lift and shift of on-premise applications that use NFS today, as well as HPC workloads which commonly also use that same protocol. I also want to add that NFS v3 is part of our multi-protocol abilities that we're building directly into our object store, where we don't have different containers or buckets with different protocols, but we have the same data at rest where you can access them concurrently with these different protocols, reducing the number of silos that you have to manage. The second feature I want to talk about is index tags. Index tags allows the user to add up to 10 indices per blob and then do a query against those indices to return a subset of the blobs that are in their account. So you can imagine that in the past, many customers would have a solution with a separate catalog or database to track their blobs as well as be able to search against that catalog to return a subset. For some of those workloads, you no longer need to have that separate catalog because you can query directly into our object store. The third feature I want to mention is inventory. With inventory, you can set an optional filter and then also specify which attributes you want to include in your inventory. And then the system will automatically generate that inventory file once a day in either a CSV or Parquet file format. This inventory file can then be used with Synapse and other tools to produce statistics such as the number of files in a container or the capacity within a folder. So it gives you a lot more functionality and a lot better control to understand what your data real estate actually looks like. Now I want to segue into looking at some specific customer examples. The first set of these are our backup partners. These are 6 of our largest backup partners who entrust their customers' data into Azure. Azure Blob Storage provides an off-premises trusted cloud store for their customers' data. Now I want to take a deeper dive into one customer, NetInspect. So NetInspect has built one of the most used enterprise quality management systems, focusing on aerospace companies such as Boeing, Rolls-Royce, Honeywell, and Raytheon. Now when you think about it, airplane manufacturing is incredibly complex, including up to 26,000 suppliers in 60 different countries. Now when they moved to Azure Blob Storage, they imported hundreds of millions of documents into Blob Storage for the sole repository for all static content. And they were able to do that based upon the encryption at rest, private endpoints, network firewall, which made securing their workload easy. I'll also add that they use Azure Functions as part of their workload to perform data import, data export, email notifications, and other components of their end-to-end workflow. With that, I want to do a quick demo of NFS v3. So here I have a portal instance that's looking at the Azure instances that I manage. And I have a specific storage account called NFS demo that I've created. Now, if I look at the NFS demo account, I can see that NFS was already enabled because today you enable it at storage account creation, not afterwards. Now, NFS v3 protocol has limited authentication or security built in, so we do require network-based security. So in this case, I have created a virtual network called demo. And so my NFS endpoint will only be accessible over this virtual network. Now, in a storage account, you can have one or many containers. And every container that's created ends up being an NFS export that can be mounted by an NFS client. So you could have many NFS exports. Now, I've also created 2 VMs, one Linux attached to my virtual network. And then I've also created another VM, which happens to be Windows, also connected to the same virtual network. Now that I have these 2 VMs, I can access my NFS export within those VMs. So here's my first one, which is my Linux VM. And so I've SSH'd in, and so now I do a mount command to mount nfsdemo.blob.core.windows.net to my Linux VM. I can now go directly into that directory. and I see that there's nothing there. So now I'm going to go to my Windows VM showing the concurrent protocol access, and I'm going to use the Azure Storage Explorer tool, which I've already authenticated to my storage account, and I'm going to pick a local file to upload. And so now after I've uploaded this file, I can go back to my Linux VM, and just for grins, I'll also make a directory, and I have to do a sudo. So let me do that again. And now I can do a directory listing, and I can show both files. Now the last thing I'll do is from this Linux VM, I'm going to also run an application called FIO, for File Input Output Testing, which will actually do multiple read-write attempts directly against the storage account across 4 different processes. So it's more of a stress test. And when I do that, I also see that file show up on the Windows side as well. So in this demonstration, I showed the concurrent protocol access between NFS as well as the Blob REST protocol from 2 different VMs running within that same VNet. Now I'm going to move on and start talking about Azure Data Lake Storage. Azure Data Lake Storage basically enables analytic workloads, which provides better insights across your unstructured data, especially when that data estate grows. Now, the fact it's built on top of our object store provides low cost, where you pay for what you use and you can scale to petabytes. And it's very open in that we enable the HDFS protocol as well as the Blob REST protocol, and now in the future, the NFS protocol, where you don't have separate silos to access that same data. So I want to provide a typical workflow for analytics in Azure. This shows on the left both structured and unstructured data, which is imported into Azure Data Lake Storage, which is the foundation for all analytic workloads in Azure. Whether you then transform using Databricks, or do advanced analytic queries using Synapse, or visualize through Power BI, it is the foundational component that drives all of those experiences. So I want to talk a little bit about what makes a data lake storage platform great. First, it's the massive scale, the high performance, and the durability that is required. Secondly, it's the requirements to secure and protect and make sure that the data is compliant with all certifications necessary. The third is the cost structure, and data lake storage being built directly on top of our object store provides that low cost performance. And lastly, it's the fact that it supports all the different analytic engines, whether it be Hadoop, Spark, or other, that customers want to use, as well as the other Azure services that we support through our multi-protocol capability. So I want to focus on a few customer examples for analytics workloads. The first one is Rockwell Automation, which is a world leader in industrial automation and information, employing over 22,000 people. They're present in more than 80 countries and focus on industries such as oil and gas, mining, food and beverage, and automotive. And they had a desire to empower their business users to have a data-driven mindset. So they created a unified platform for all their analytics needs, optimizing storage, compute, and scale while reducing their TCO. The process they used was to ingest all of their data into ADLS Gen 2 using Azure Data Factory. They then did transformation and curation using Azure Databricks, and then loaded the data into Azure Synapse Analytics, as well as using Azure Databricks, Azure AI, and Azure Cognitive Search for other analytics scenarios. Now, the second customer I want to talk about is Smiths. Whether you've traveled by air, had a doctor's visit, or used your phone, or even heated or cooked in your house, you've probably interacted with a device or solution from Smiths. They had multiple businesses with separate data repositories, which required manual extraction when they wanted to provide insights across those businesses. What they did is they consolidated by ingesting into Azure Data Lake Storage Gen 2 using Azure Data Factory. They then transformed via Azure Databricks and then consumed via Power BI. Now with Marks & Spencer, their scenario was to pull Parquet files from their on-premises HDFS clusters into ADLS Gen 2, and then use Databricks to transform and Synapse to run visualizations and create a dashboard. Lastly, there's ABN AMRO, which moved from a centralized model to a data mesh architecture based upon ADLS Gen 2. Lastly, I want to talk about a partnership we did with WANDisco to provide a turnkey solution for Hadoop-oriented data lake migrations, the WANDisco Live Data Platform for Azure. With the Live Data Platform for Azure, you can deploy and manage your data lake migrations using the same Azure management experience that you enjoy today through our portal or command line experience. You can begin your data lake migration in minutes and not weeks or months like you would with other solutions. Most importantly, the Live Data Platform for Azure allows you to begin migrating your Hadoop-oriented data lake into ADLS Gen 2 with zero business downtime. The Live Data Platform is integrated with Azure and provides the same metered pay-as-you-go billing model as other Azure services, which means you also get it on the same Azure monthly bill in the same way that you can track and monitor your usage through time. Please check out the details in the Azure Marketplace. And additionally, I want to underline that the first 25 terabytes migrated is free. So there's 3 takeaways I want to underscore. The first is that Azure Blob Storage and Data Lake Storage Gen 2 powers Azure's unstructured and data lake storage, providing durability, security, and extensive data management and cost control features. The workloads that it provides support for includes everything from cloud native to analytics, HPC, ML, AI, as well as backup and archive workloads. And lastly, we have flexibility in consumption, where you can do pay-go as well as reserve capacity to pre-purchase to lower your costs even further, and use the features that I mentioned, such as lifecycle management, which can lower your costs significantly. Thank you for joining me today to learn about Azure Blob Storage and Data Lake Storage Gen 2. Here are some links to learn more. Thanks again, and I'm off to see if we cleared 360 billion transactions during the session. We are just getting started.